I am at King's College, London, in the Wheatstone Laboratory. Once presided over by John Hopkinson, now controlled by Professor Ernest Wilson, who has lent it for the occasion. I'm going to speak about emptiness, vacuum, what we commonly call empty space. We are usually concerned with matter, which consists of particles. But I'm concerned with the space between the particles, or the space between the worlds, space which we commonly call empty. It makes no impression upon us, and whether that space contains anything or whether it is really empty is partly a matter of opinion. I prefer to call it ether, but some people prefer to call it simply space. The name you give to it is of no consequence. The first thing we learn about empty space is that it can be thrown into vibration, tremor, a quiver. You use this tremor when you toast bread in front of a fire. Or if you sit in front of a fire, people think they are feeling hot air, but they're not. They're feeling the vibrations of empty space or of ether. I am now in a bath of vibrations, ether vibrations. The result is I'm rather warm. For when these vibrations fall upon matter, they produce heat. They may produce other things too. They may produce photographic plates. Or they may produce vision. The skin is sensitive to the vibrations, and you feel them in front of a fire, or you feel them in the sunshine. The eye is especially sensitive, and I have somewhat do in order to see in this bright light. The lamps agitate space. They agitate the ether. I am agitating the air. My voice throws the air into vibrations. The lamps throw the ether into vibrations. And there is a machine for picking them both up. By one machine you hear what I'm saying. By another machine you see what I'm doing. And they're both being recorded on the film. Now, air is gaseous matter. Don't confuse air and ether. Air is gaseous matter. The ether is nothing of the kind. What the ether really is, except emptiness, I'm not going to tell you because I don't know. But we know something of what it does. And I'm going to show something of what it does. Next time you're in a blaze of sunshine, just remember that what you feel has come through 92 million miles of emptiness. The air has nothing to do with it. The heat that you feel is produced when all this quiver, this ether tremor, impinges on matter. Matter does not convey it. Matter destroys it, absorbs it, turns it into heat. You're looking through a tremendous lot of vacuum when you see the stars. Now I want to show not only that empty space can transmit light easily, but that it can also transmit force. possible to balance a weight of an empty space. That sounds curious, but it can be done if you put the space into a peculiar state. Now, to show that, I take this little arrangement here. Here is a bar. It's made of iron and cobalt, cobalt steel. If I place it on this guide, it just has guides to prevent it tumbling about, and let it go, it oscillates. You can see it oscillating up and down. There's nothing to support it. You're not to suppose that the air supports it. It is like on a cushion, but it is a cushion of empty space, cushion of emptiness. One may explain it and put it in various forms. One knows really that there is a magnet in this piece of wood below, which is repelling the magnet above. And it's only recently we've been able to show a body supporting its own weight by repulsion. But that doesn't really explain it. You're not to suppose that you understand those things because you call them names. The real point is that there is nothing supporting that. It would do perfectly well in a vacuum. Put it in as perfect a vacuum as you have, and the thing would behave exactly the same. Space is what we're experimenting on. And it is because space has these physical properties that I prefer to call it ether. But the name ether has rather gone out of fashion. There's another experiment here just to illustrate this cushion of ether. Here are two bars of steel, and you see, if I, now they're trying to collide against one another. There's evidently a cushion between them. Very simple experiment, and if you look at it from the engineering point of view, of no consequence, but if you look at it from the philosophical point of view, there is something quite remarkable in the collision of particles with a cushion, with nothing but a cushion of empty space to separate them. Remember, this would go on in a vacuum too. And the real particles of matter are all in a vacuum. The particles that Sir Ernest Rutherford was talking about, the atoms, are all in vacuum, and they repel one another, something after this fashion. The worlds only attract one another, but the particles of matter can also repel. But remember that when you use the word repulsion, you're not explaining anything. You saw there was an elastic cushion between those two bars, and this leads us to the real meaning of elasticity. When we strain a spring, we commonly think that the matter is strained, but that is not so. It is the uniting mechanism between the matter that is strained. Just as I put one load on the other on an elastic cushion, so now I put a load on what looks to be a visible elastic cushion, namely a spiral spring, which is squeezed down by the weight or by a force. I feel the elasticity. What am I feeling? Just consider the meaning of elasticity. Here, for instance, is a spring which I can bend. It is now strained, something is strained, but the matter is not strained. The particles of matter are merely moved. I take the particles from where they were, and I put them here. That's locomotion. That isn't strain. You can't strain matter, really. You can only move it. Locomotion is all that you can do to matter. You can't move space, but you can strain it. Now think what's happening. Here are a number of particles connected somehow. How? By what we call cohesion. What does that mean? Well, we don't know what it means. But it's something in the intervening space between the particles, as if they were connected by so many little elastic threads. It is those threads, it is that substance which is strained when I move the particles. I move the matter, I strain the ether. So it recovers, springs back. Of course, you can spring too far and oscillate. So the strain goes into the ether on the other side and then comes back. It's the same with a pendulum. It doesn't always recoil. There need be no connection of that sort between the particles. Here I have another strip. I take and bend that. I strained it all right, but it doesn't spring back. It stays put. Well, that's because it's lead. That, of course, recovers. Very well. It's the substance between that is being strained, and that is the theory of springs when properly contemplated, philosophically contemplated. Here is a spiral spring like this, with a weight attached to it, and the weight can jump up and down in accordance with the strain between the particles, the strained ether, and the moving weight. And the energy goes from ether to matter alternately. And if I had time, I could elaborate that a good deal, because that is what is always happening in all the activities of the universe. Energy is passing from ether to matter and back again. All kinetic energy, all moving energy belongs to matter. Matter is that which moves, cricket balls, railway trains, anything. Strain belongs to the ether, to space. It is the connecting medium. It unites the particles, it unites the worlds. But now there you have a different kind of strain. If I take a weight and raise it, the experiment is the simplest one could possibly perform. It's so simple that you find it difficult to attend to it. It's difficult to realize that there's anything puzzling about simple weight, but there is. We know it's due to the neighborhood of the Earth. The Earth, as a big body, has thrown the space all around it into a state of strain. And it's the result of that strain which pulls bodies down towards the Earth. I can set up a strain in artificially, which might have the opposite effect. Instead of pulling bodies down, it'll throw things up. You might call it a principle of levity instead of a principle of gravity. Here, Professor Wilson has arranged a ring around a magnet. Never mind that. It's a device for throwing space into a strain. We don't know much about what the strain is. We may call it names. But we must be much to learn about it. When I throw that into a state of strain, instead of the body falling, it rises and floats. It would be thrown right off if it were not tied by strings. It's tied so that now, see there it is, oscillating. If I try to push it down, it jumps up again. Now suppose I cut those strings and put the ring on again, or a lighter ring I put. And now once more